Hello everyone, I'm Shashikant. We are discussing about power in CMOS. The overflow of this topic will be the introduction, importance of low power, applications and conclusion. So what is the introduction? So in the introduction, the power present in the CMOS is a mainstream of focus area. The whole circuit working is depend on the power consumption. The CMOS logic dissipates a less power than the NMOS logic circuits because the CMOS dissipates power only when the switching. The CMOS gates are very power efficient because they dissipate nearly zero power when ideal. So the power consumption in CMOS is given below. So first is dynamic power consumption. So it is happened due to the charging and discharging of the load capacitance. The CMOS circuit dissipates a power by charging the various load capacitance whenever they are switched. In one complete cycle of CMOS logic, the current flows from VDD to load capacitance to charge it, and then the flows from the charge load capacitance to the ground during the discharging. So next is short circuit currents. So there is a finite rising or fall time for the both PMOS and NMOS during the transitions. For the example, like from on to off, both the transistors will be on for a small period of time in which the current will find a path directly from VDD to ground, hence creating a short circuit current. The short circuit power dissipation increases with the rise and the fall time of the transistor. The third is leakage. The leakage is consumed for more power because of the leakage current. So the leakage current is through the thinner gate dielectrics because of the current tunneling through the extremely thin gate dielectric. The leakage power is significant portion of the total power consumed by the designs. So next our main important topic is the importance of the low power. So there are the 5 benefits of the low power and these are given below. So first is increasing the device density, second is increasing speed, third is battery life, fourth is green concern, fifth is user experience. So let's see the first one. So what is that first one? First one is that increasing the device density. So in that the transistor geometrics are the shrinking and the more functionality is being packed in a design. So we have to more functionality being packed into smaller areas, thereby increasing the gate per unit area. So thus there is a more heat being generated within the same area, causing the junction temperatures to increases. Higher junction temperature reduces the reliability of the design. The need to maintain the junction temperature puts a requirement to put the higher effort in dissipation either through the heat sinks or we have to provide the costlier packaging. So the next part is the increasing speed. So the transistor in this the transistors are being smaller and they are also being faster. So increasing frequency means the energy consumption is lesser duration, so thereby increasing power. So this is also raise the junction temperature, thereby the causing the issue of the reliability and the performance. The third factor is battery life. So as we see in the diagram, we can see the number of batteries which are the portable batteries. So it is the main issue with the portable devices. So every portable device contain battery in it. So the less use of battery means more power saving, which is held used to the battery for a long time. Most of these current generation portable products are in the consumers or a communication segments. So next, the fourth one is green concern. Earlier, the concern around the environment and its sustainability was mostly a matter of concern for environmentalists only. The environment conscious movement took on a stronger and a wide world focus. The products are being characterized against their carbon footprint and energy efficiencies. Hence, the designers are putting in more effort to reduce the power in order to conform to these movements and the legislations that has resulted. The fifth one is user experiences. There has been an advent of the applications such as gaming, video streaming, AutoCAD softwares which are we are using, so they are required the more power. So for that their user experiences needs a more higher performance and if you want the higher performance means you want higher power consumption. So when the user is using the same devices for the other applications which do not need this high performance, so it should be able to conserve the battery for a longer durations, and the power should be saved as applications performance like the messaging which is requires the less power. So the next is the applications of the low power. So first, this we can use in the smartphones as we can see in the images. Next we can use in the digital cameras for the low power. We can use a portable medical devices, other low voltage power sensitivity applications. So what is the conclusion of that? So in the IC technologies, the low power consumption is an important area for the growth of number of ICs in a particular area. So for the better performance of IC is achieved due to the low power consumption. And here is that the power saving is increased because of the low power consumptions. So thank you.